Hey guys, and welcome to our video on the insertion sort algorithm. In this video, we'll explain and demonstrate how the insertion sort algorithm actually works and how it sorts an array of numbers. So we're going to divide this video into two parts. In the first part, we're going to take you through a worked example, alright, a step-by-step worked example in which we show you how the insertion sort algorithm actually sorts an array. Alright, and in the second part of this video, we're going to show you the code and explain it as well. Alright, so let's begin. So here's the list of numbers that we'll be sorting. Okay, so let's take a look at the initial phase of the insertion sort algorithm. And this is what we get. Alright, now let me explain this. The logic of the insertion sort algorithm is to sort of divide the array into two parts, a sorted array and an unsorted part. Okay, now we're not actually dividing anything here, it's all the same array, we're not creating a new array, we're not doing any partitions. Alright, we're just sort of creating a mental divide. Okay, by basically what we do is that we start the iterations from index 1, okay, not index 0. So we start from 7 instead of starting from 3. So that sort of creates a visualized divide between this part of the array and this part. Now, why did we separate 3? Well, the reason is that we're creating a sorted array. Alright, this is the sorted part. Alright, this first box here is the sorted part, and this is the unsorted part. So you might ask, how is 3 sorted? Well, 3 is automatically sorted because it's the only element in that part. And by default, any one element in the list means that it's a sorted array. Okay? And now let's actually begin the sorting process. Okay, I'll explain everything as we proceed. Right, we're currently pointing to 7 over here, right? Because I is equal to 1, okay? And 3 is I is equal to 0, 7 is I is equal to 1, and 1 is I is equal to 2, okay? Now, let's actually begin. What we're going to do here is that the value that's currently being pointed to, in this case, which is 7, we're going to compare 7 with the value before it, okay? If the value before it is larger, okay, we're going to swap the two of them, okay? But if not, we're just going to increment I. So basically over here 7 is larger than 3, or 3 is smaller than 7, okay, whichever way you want to look at it. But basically we're not going to be doing any swapping over here. So we end up with this. We just incremented I, and we now consider 7 as part of the sorted array, okay? Because now 3 and 7, because you can see this is sorted. Okay, so we're currently pointing to 1 now. Now we're going to compare 1 to the value before it. What is the value before it? 7. 7 is larger, okay? So what we're going to do is swap 7 and 1. And now we get this. We have 3, 1, and 7. We're now going to swap 1 and 3 over here, okay? Because 3 is larger. And we end up with the following situation over here, okay? 1, 3, and 7. Now listen, there are two conditions under which we don't do the entire comparing to the last value and everything. Alright, there are two conditions under which we don't do this. The first condition is when we're basically when the I is equal to 0. Okay, when we're pointing to the first value or the 0th index. Okay, the reason behind this is pretty obvious. Is because there's no value before it. Alright, so there's nothing to compare to. And the second condition is something we've already seen, is that when the value before it is smaller, okay, we saw this with 7 and 3, because when I put 7 into the sorted array, okay, we didn't have 1 here back then, so when I put 7 in here and 3 was before it, I just saw that, okay, the value before 7 is 3, right, it's smaller, right, and we'll stop there. Okay, there's no need to waste any more time by iterating through the entire sorted part and checking everything. Okay, we just stop right there, and we'll see this actually as we proceed. Okay, so let's go ahead and move to the next iteration. Okay, and we're now pointing at the value 0 at index 3. Okay, so basically 0 and 7. Okay, we're going to compare the two of them. 7 is obviously larger, so we're going to swap the two. Okay, and here we go, 1, 3, 0, 7. Okay, now the value before 0 is still larger, so we're going to swap it again. And the value before 0, which is 1, is still larger, so we're going to swap it once more. And we've now triggered one of the conditions necessary for the comparisons to stop. Okay, so we're going to stop right here, and we'll go back to pointing to the next value, which is 8. Okay, we're now pointing at 8, which has the index 4. Okay, and well, what do you know? 7 and 8. 8 is larger, so we'll just move on, all right, to 6. Okay, we're now pointing at 6 and the index is 5. We're going to compare 6 and 8 now. 6 is smaller than 8. Okay, so we're going to swap it like this. Now 6 and 7. Okay, 7 is larger. All right, so let's swap that again. And guess what? 6 is now in a sorted position. 3 is smaller than 6. Okay, so there's no point in swapping. All right, we're sorted. Okay, now we're pointing to the value 5. We're now going to compare 5 and 8. 8 is larger, so swap. 5 and 7 now. 7 is larger, so swap. Compare 5 and 6 now. 6 is larger, so swap. Okay, and now we have 5 in its correct position. Okay, we won't go any further because 5 is larger than 3. Okay, or 3 is less than 5, so we won't swap. We now have a fully sorted array. Now what's actually going to happen here is that we're going to point back to 9, and then we'll see that 9 is larger than 8, or 8 is less than 9. So then we'll stop right there because we know that the entire array is now sorted. Okay, we're done. This is all it took. So that's enough with the worked example. All right, now let's move on to the actual code. All right, if something wasn't clear, or maybe you had trouble understanding some concept, maybe you'll understand that better once we take a look at the code. Okay, so let's go on. Here we have the code for the insertion sort algorithm in Python. Okay, it's pretty simple, pretty straightforward, and you can replicate it in any language easily. Okay, so here's the array that we're going to be sorting. We pass it into the insertion sort function, and over here is where we begin with the insertion sort code. Okay, now notice something interesting over here. In this for loop, we would typically begin from 0, right? But over here, we're beginning from 1. Why do you think that is? That's because, as I mentioned earlier, we always ignore the first value in the array that we're sorting, okay, in insertion sort. The reason is that we consider that as the sorted part of the array. If you remember that we separated 3 earlier in our worked example, okay, so that's why we did this basically. We were basically just ignoring the first value, okay, assuming that to be the sorted part. So that's why we begin from 1, okay. We're not going to be touching the first value. So over here is where we pick the sort value. Now remember how we would pick a new value every time we reset? So this is basically that code, okay. So since I is currently 1, okay, we're starting from 1. So the first value that is selected is going to be 1, the value at the first index, okay. You can go back and check the slides again, okay. So if you don't understand anything over here, it'll all make sense if you compare them side by side, okay. Now here's the while loop, okay. This is basically the main core, all right. It's the chunk behind the insertion sort algorithm. If you understand this, you've understood the insertion sort algorithm. So basically, I mentioned that there were 2 conditions, right? 2 conditions for stopping the comparisons and checks. And this is actually these 2 conditions. Here's the first one that I mentioned, that I must be greater than 0, okay? And the second condition here is that the value before sort value must be greater than sort value, okay? So if these 2 conditions are fulfilled, then we will do the swap. We also decrement the value of I, and the reason we do this, of course, is because we keep decrementing until one of these 2 conditions have been broken, all right? So while these 2 conditions are true, we will continuously decrement I, okay? And of course, once this is over, once one of these 2 conditions is broken, we then go back to the for loop, which then begins with the next value of I, okay? So the value of I is basically reset. And of course, once all this is done, we then have our return statement over here that returns the value of array back, okay? And we then print it out over here. Now let's actually run this code and see the sorted output for this array, okay? And here's our output, okay? We can see that it's fully sorted. That's good. Okay, so we're basically done here. Just a few more things I want to mention, that you can find the code for this insertion sort in the description below. I'll include a link to the website, as well as include links to other sorting algorithm videos if you're interested, because this is actually an entire series on sorting algorithms in which we cover like about 10 different sorting algorithms, all right? So beyond this, you can also find a lot more content on the website, like stuff like time complexity and comparisons to other sorting algorithms. You can learn a lot more. So be sure to check that out if you're interested. and make sure to subscribe so you don't miss any future content, and I'll probably see you in a later video.